Okay, so what I claimed was a pretty easy example didn't actually look that easy in the last video. When you go to actually get the answer, it's not something compact, right? The answer is complicated with irrational expressions in it. So let's look at a function that we would think would be a really easy one, aside from y equals a straight line, okay, y equals x, or y equals mx plus b. This is about as simple as it gets. And a straight line is boring. We don't need calculus to find the length of a straight line between 2 points. So this seems to be about the easiest function we could work with, but it turns out it's not easy to use in this formula for line length. All right, so let us go through the steps. Okay, so in order to use the formula, we first need to know what dy dx is, right? So in step 1, that would be easy. That's 2x. In step 2, we need to square this. So that's 4x squared. Step 3, we need to take the answer we had and add 1. Whoops, and I have a mistake in the formula. That should be a plus in the formula. So we're adding 1. Doesn't matter if we put the 1 in the front or behind since we're adding. So we end up with 4x squared plus 1, or 1 plus 4x squared if you prefer, right? So step 4, we need to take the square root of all of that. Actually, I'm going to do step 4 and 5. I think it's pretty easy to see what the square root of that would be without, and it doesn't simplify. So I can say that the length is the integral from x equals 0 up to 2 of the square root of 4x squared plus 1 integrated with respect to x. All right, now when you look at this, it's not on the memory list. You might try a u substitution, but that's not going to work because the derivative of 4x squared plus 1 isn't there. It might work with a trig substitution, but not the one that we learned. We learned how to let x equal a constant times the sine of theta. That's not going to work here because this has the plus in it. So with the plus, we needed that to be in the form of 1 or a squared minus x squared, and then subbing that x is equal to a sine theta worked nicely. There are some other trig substitutions that can be done that might work in this case, but we didn't learn those. So all of the tricks that we learned are off of the table. So the only thing really to do is to evaluate it numerically. And so you could put this problem into MATLAB. You could say, let y equal x squared. And then you could go from, notice this would be x equals 0 up to x equals 2. So be having the y coordinates don't really help you when you're trying to find, when you're doing the integral. You just need to know what those x coordinates are if this is a function of x. Turns out the book does go over this, but I'm not going to go through this now. Sometimes it's easier to use the inverse relationship to get x in terms of y, and then you would want to use the y coordinates instead, and you'd have a pretty analogous relationship there. But in this case, we're stuck. Okay, what I would recommend is probably the fastest is not to boot up MATLAB and try to do this. Just write in your TI-84 or whatever calculator you're using, go down to the math and the function int, or it might actually have the integration sign. It might have this sign down there. All right, and just put that in and integrate the square root of 4x squared plus 1, comma x, comma 0, comma 2, and you will get an answer for that. Okay, so there is no nice answer for that that we can find easily. So you can just set up the integral and evaluate it on your calculator. In fact, on some of the homework problems, that's what they say to do. So setting up the length integral isn't bad, and evaluating that in a calculator is quite easy, but we usually can't get nice answers where we don't have to use a calculator. And by nice answers, I mean things that are exact. So there are just a couple of cases that work exactly. All right, here's another one. If we Whoops, sorry about that. Let's have y equal the square root of x. You might think that that would be a pretty easy one. Let's go from 1 to 4, and we'll just quickly see that this one also becomes a calculator problem. So if you do step 1, dy dx is going to be 1/2 x to the negative 1/2, which is 1 over 2 root x. Get to step 2. We square all of that. I do recommend breaking out the steps. Step 3, add 1. And you might say, oh, let's try, what if I do, 1 plus 4x over 4x? So you could rewrite that algebraically that way. Now step 4 will be to take the square root, and this is another case where, because it's a fairly simple one, I would maybe combine step 4 and 5. So we're now ready to say that the length is the integral from x equals 1 to 4, and we could use either one of these expressions. So I will use 1 over 4x plus 1 integrated with respect to x. Oh, and I forgot, we step back. I'm combining step 4 and 5, and that's why this doesn't work so nicely. With the square root on there, this does not have a nice antiderivative, right? It doesn't match anything that we've seen. And if we had used the other version of it, we could let u equal 4x or 1 plus 4x. It's just not going to help, all right? In fact, using 1 plus 4x for u makes it worse. So that isn't going to help us to get anywhere. So at this point, we're stuck using the TI-84 or some other numerical method to get an answer. All right, so it's pretty easy to set up the length integral. Actually getting an exact answer is hard, so we can get a numerical answer quickly. And by numerical answer, it's going to be a decimal answer. It can be very, very precise. It's pretty quick on a calculator to make that precise to the 10,000th place or the 100,000th place. So it's not a bad answer. It's just not exactly the right answer. But let me point out one more thing in this problem. You'll notice I started at 1 and not 0. The reason I have to do that is because if I look at the derivative, dy dx, it does not exist at 0. So I could do an interval from 0.0001 to 4 if I was numerically trying to find what the answer is. That wouldn't be a bad way of trying to figure out what approximately the answer is from 0 to 4. But I can't actually go all the way from 0 to 4 because the derivative does that. Which is a reason you might want to rewrite this as y squared equals x, and then do the whole thing in terms of y, but you'll have to look in the book about how to do that.